Welcome back to section 5. In this video we look at the general exponential function. So the general form of the exponential function can be written as y equals k times a to the power of x plus c plus b. By observing the graphs A controls how steeply the graph increases or decreases. Secondly, B controls vertical translation. So for positive B, the graph moves upwards, and for negative B, the graph moves downwards. So think of this like when we were completing the square with the polynomials or the quadratics, or think about how we were doing the vertical translations with the trig functions. So this B at the back of here controls the vertical translation. Now for the variable C controls the horizontal translation. So C controls horizontal translation. And what we find is for positive C, the graph moves left. And for negative C, the graph moves to the right. Going down, our fourth feature is the equation of the horizontal asymptote is y equals b. And y equals a to the negative x is a reflection of y equals a to the x in the y-axis. Similarly, y equals negative a to the x is a reflection of y equals a to the x in the x direction. So going down to some graphing to show off these features. Now, when we're looking at the particular shape of these particular functions, there are going to be three different shapes that will occur. So the first one, with what we've seen already, is a graph that looks like this here, with the asymptote like so. The second situation that we could see is a graph that looks like this, and the asymptote for this one is going to look something like this for this graph. Now going over, another shape that we could encounter is something that looks like this with the asymptote like so. And the final one that we have to get used to seeing is a graph that looks like something like that, where the asymptote is like so. Now the conditions for triggering these types of graphs is that we find that it's controlled by the variables k and a. So k and a together control the orientation of the curve. So on the one in the top left, we have a curve. A curve, when we see this, we know that our conditions for k and a are going to be where k is greater than 0 and a is greater than 1. Going down, for a curve in the bottom left, we're going to see conditions where k is less than 0 and a is greater than 1. For a curve in the top right, we're going to see conditions where k is greater than 0, but a is between 0 and 1. And for the bottom right, we're going to see these conditions triggered when k is less than 0 and a is between 0 and 1, like so. going downwards. Now, the simplest way to do this is simply write out the general form that you expect to see for a graph like this. And you'll know that the general form of a graph is y equals k times a to the power of x plus c plus b. So what we can see listing all of these variables is that our c is going to be a value of 3, and our b is going to be a value of -1. So instantly what we know is our horizontal asymptote is going to be at y equals -1. Secondly, we're going to see a horizontal translation because of the factor of c. So we'll see a horizontal translation. And because this is +3, we're going to see the graph shifted 3 units left from where it would otherwise be positioned. And think about the location of the asymptote. We're going to see a vertical translation now. Vertical translation of -1. So we're going to see 1 unit downwards. So if we were to graph, say, a regular function of y equals 2 to the x, then what we'd expect to see is plotting the points for y 2 to the x. We remember that it looks something like this. Like so. But consider this is the graph y equals 2 to the x. We want to do it with all of these translations in here. So what we're going to go for is, firstly, we have to put in our asymptote. So we're going to get shifted downwards by -1. So I'll put in an asymptote here, and this will equal y equals -1. And then we know that we're going to be shifted to the left by 3 units. So what we find is that this starting position here is 1, 2, 3. So it starts, we'll do it in a red pen. It starts back at -3. So if I were to put in the points, we'd go down 1 here, then across 1 would go, so we go up to here, then we're going to double here, then finally 1, 2, 3, 4, we're going to cross at 7. Now going downwards, we're going to go backwards, we go a half. So putting this graph together, what we find is that our function for this instance is going to look something like this. So notice, looking at the function, for the equivalent points, we're always 1 up and 3 across from the reference function of y equals 2 to the x. So this red function here is indicative of y equals 2 to the x plus 3 minus 1. Now going down and looking at the domain and range, for this particular function, we can explain the domain as being d equals x for all values, all real values of x. And the range can be written as the values of y such that y is greater than -1. So we'll leave it there for this video, and in the next video we'll jump into question example 2a.